Welcome back. Let's take a quick look at acid-base chemistry. Alrighty? We are going to be looking at what's an acid and what are some science examples of acid as opposed to what's around your house. Base. What's it do? What's it made of? Some science examples. What's around your house? Then we're going to talk about where are these things on what we call the pH scale. And then, what's a buffer? And again, how do I use it? Give me some examples in science class. Give me an example of what's happening at the house. All right? Okay. And of course, always be thinking of possible test questions when I'm teaching this stuff. Here we go. Let's go to the board. Okay. The best way to explain what an acid is, easiest to put on a flashcard, gives off H's. That's what it does. It gives off H's. It's the H's that burn you. Got it? Not the other half of the acid. It's the H's that do the burning. So, what are some examples? And please note, I'm writing in pink or red because guess what? Acids stain red or pink. What do bases stain?
Purple or blue.
Yeah. Okay, so here we go. What are some examples? Well, HCl, HBr, H2SO4, H2CO3. Hydrochloric acid, hydrobromic acid, sulfuric acid, carbonic acid. See how that works? And what do they all have in common, which makes it easy for you to distinguish on a multiple choice test? They all start with H. Because it's telling you that's what they do. They give off this H. They give off that H. Okay? And that's what an acid is on a Mr. Weber test. So, what are some acids around your house?
Lemon juice.
Lemon juice. And tomato juice. Got it? And pickles and vinegar. What do all of those household items have in common? Sour. Guess what sour is? H's touching your tongue. Those are H detectors, hydrogen detectors. Of course, it's not hydrochloric acid. You're not going to drink this and you have no tongue. Got it? It's going to dissolve. No. But a little bit gives you that sour taste, and we like that sour taste. How do we know that? Because you have sour taste buds on your tongue. That's how we know we like it. We got sweet, right? And all that kind of stuff too. Umami. All right. Everybody good? So that's what's around your house. What is the definition of a base? Well, I've got two definitions for you. It picks up H's, but the other definition that I like is that it gives OHs. It gives off hydroxides, OHs, which are OH with a negative. Why is it a negative? Because O is -2, that's +1. What's +1 and minus? What's -2 and +1? -1. Okay? We call this a polyatomic ion, more than one atom. Okay? Alright, so what are some examples? How about compounds that end in OH? LiOH, MgOH2. Oh my goodness. See where the OHs are? They're at the back end. Because it's negative. Where are the H's? On the front end. Because it's positive. And if you remember the periodic table, where are all the positives? On the left side. Where are all the negatives? On the right side. And how do we read in America? Left to right. Got it? Positive one first. Everybody with me? Now, here is what I want to make sure you put on your flashcards. The two exceptions to the rule, it ends in OH. Or it begins with a metal and ends with OH. Ooh, if it begins with a metal and ends with an OH, it must be an ionic compound. Oh, wow. Okay, now, what are the two exceptions? NH3, which is ammonia. I don't see an OH here, but guess what? Ammonia picks up H's and becomes ammonium NH4. So it picks it up. What's the other one? HCO3. This is bicarbonate. Bicarbonate. This has a negative charge. You see, it's basically H2CO3 minus one of the H's. So guess what it wants to do? Pull that H back. Well, that's the definition of a base. Picks up H's. So both of these are going to pick up H's. Now you might have heard this word bicarbonate because this is your science class. How about at home? Tums. Ever heard of that? Yeah. Tums is calcium. This is not working. Tums is calcium bicarbonate. What's Rolaids? Sodium bicarbonate. What's milk of magnesia? Magnesium bicarbonate. And what do we use all three of these things for?
Stomach acid.
If you have stomach acid, got it? So this is what we call an oops, I gotta spell it right. Antacid. It's an anti-acid, it's a base. Well, guess what, my friends? This is what I would teach if I was teaching a chemistry class. If you spill an acid, you clean it with a base. If you spill a base, you clean it with an acid. Because an acid neutralizes a base, and a base neutralizes an acid. You know what else we call that? A buffer. That's on the word there, right? Okay, I'll talk about buffers in just a second, because the next thing was pH scale. Got it? Well, the pH scale goes from 1 on one end to 14 on the other end. Okay? Now, I think technically it goes from 0 to 14, but I like a number. Okay? Gee, I wonder what's dead smack in the middle.
Water.
I know, what's the number?
7.
7. Okay. So right here is a 7. Okay? Well, this end is acid, and from here over is base. Got it? So what do we call this thing in the middle? Starts with an N. Neutral. Spell correctly now. Neutral. And what's neutral? Pure H2O. Now I'm going to put down pure here. Alrighty? The only pure H2O you can find in the grocery store is distilled water. You are not going to find pure water coming out of your faucet. Okay? Because they've added chlorine and all sorts of other stuff to it. Alright. Here is what you need to put on your flashcard. What is our blood pH?
7.35 to 7.45.
Exactly. So we're right here. 7.35 to 7.45. Okay? So, what are we? Slightly basic. Okay? Slightly basic. If your patient's pH is heading towards 7 and beyond, you are in acidosis. If your patient's pH is heading towards 14, though of course you'll be dead, but you are now alkalotic. What's the worst pH that you've been studying in class?
We actually haven't gone over it yet,
okay.
But we're actually doing that this semester.
Mm-hmm.
Yeah, once it gets below 7.35.
Yeah. Yeah, I mean, so if your patient has a 7.0, they're already in danger. You might say, oh, well, neutral should be fine. Yeah, if you're a glass of water, but not if you're a person. Does that make sense? Because whenever we get too acidic, we're already starting to denature the important proteins that keep us alive. Okay? And remember, we denature with too much base also. So when we start heading towards 7.5, 7.6, 7.8, by the time you're 8 something, you're dead. Because that pH is too basic. Everybody good? Okay. Now, how do I make sure that my pH stays where it's supposed to be?
Buffer.
A buffer system. Alright? Just like we use this base, any one of these, to offset the acid of your stomach, we are going to use a buffer system in the blood to offset too much acid or too much base. So let's first explain, do you mind if I erase this here? Let's first explain what is neutralization. Well, if I have hydrochloric acid plus a base, sodium hydroxide, what am I going to make? I'm going to make sodium chloride, which we call salt, and what? H and OH. What do we call this? Water. Got it? So we have an acid and a base becoming salt and water. That's neutralization. My acid is no longer acidic, and my base is no longer basic. Which is why I mentioned earlier in a chemistry class, we tell our students, if you spill an acid, you clean it with a base. You put some base on it, and now you're cleaning up salt water. If you spill a base, put a little vinegar on it. Now what are you doing? Cleaning up salt water. And I say that because, have you ever seen those big tanker trucks that are carrying hazardous material? Thank goodness they have that triangle, that hazmat, which tells the first responders what's on it. Not in words, but in symbols. Okay? You might also see on the outside of a truck the word corrosive and the word caustic. You see, both acids and bases will burn you up. You touch it, you're going to pull back a skeleton. Alrighty? However, if you don't clean them up the same way, got it? You don't deal with them the same way. So that's why they've used the word corrosive to mean acids are being carried in this tanker, and caustic means I'm carrying a very powerful base. Okay? Now, acids and bases are used in industry, got it? To make things and to cut dyes and stuff like that. They're very strong stuff. But when they fall over, the first responders got to know what to clean it up with, or they're going to get hurt. 10-4? All right. And there's lots of stories I can tell you in class about examples of this. All right, so acid plus base leaves salt and water. Okay, we're not necessarily making salt and water in our blood, but we are using an acid to neutralize a base and vice versa. What are we talking about? Well, your red blood cells contain I already erased it, darn it. Okay, so your red blood cells contain H2CO3, carbonic acid. This is made from H2O and CO2. See? H2, C, and then 3 O's. Okay? Now, this thing is a weak acid, and your red blood cell can break that into an H, which is an acid, and HCO3 negative, which is a base. Got it? Remember? Base, bicarbonate. All right. Your red blood cell is holding this right now. 10-4. If it realizes that the conditions of your blood are too acidic, it will release this piece and hold that. If your blood is too basic, it'll hold this piece and put out this. Got it? Too much base, add an acid. Too much acid, add a base. That's a buffer system. And that's the system that keeps your blood between 7.35 and 7.45 all day long. Got it? It's when you have different conditions and all of a sudden your blood buffer system can't handle it that we have to look at other body parts helping, like your lungs and stuff. We'll talk about that when we get to another chapter. Okay? But that's your buffer system. Does that work? Okay, so thank you very much.